Hey class, today we're going to be working on how to make a five-sided box, which is the same as regular box, but it's missing one side. Quickly, I want to remind you about Noun Project, which is a great place to get SVG files. These are vector files of anything, such as the sprinkler, which we used earlier in class, or, I don't know, a saw. Anyway, it's a great place to get vector files. So there, I found this flower. I'm going to download it as a basic download in an SVG format. And I'm going to open that in Illustrator just so we can have these open already. And the only thing I'm going to do here is I'm just going to delete the text and save it again. This way we can import these into Fusion when we're done. But I'm going to leave this one alone. I'm going to make a new file with the file menu and then new design. I'm going to save it first because I want to be thorough. I'm going to call it, I'm going to put it in this folder, and I'm going to call it five-sided box screencast. Now the first thing I'm going to do, as we talked about, rule number one is create a new component. And this is just going to contain the first thing I build. And the first thing that I'm going to build is going to be the bottom of the box. So I'm just going to call that bottom, and it's empty. And then I'm going to go to the modify menu and make some parameters. I have it pinned up here so I can open it faster. And I'm going to make a parameter called thickness, as always. And I'm going to make this 3 millimeters for now. I'm also going to make a parameter for width, height, height, length, and width. But instead, I'm going to call them X, Y, and Z. And the reason for that is because it'll make things less confusing. And the reason it will make things less confusing, 150, Z, 200. And the reason why calling them X, Y, and Z will make them less confusing is because they're labeled right up here. And it'll just mean that you won't have, like, which height is always obvious, height is bottom to top, but width and depth, or whatever you want to call them, always get confusing as to which one's which. So I'm going to call them X, Y, and Z, and X is going to be right to left, Y is going to be front to back, and Z is going to be bottom to top. And the numbers I use for those don't matter so much, but I used 100 millimeters, 150 millimeters, and 250 millimeters. So I'm going to make a new sketch, and I'm just going to put it on the bottom. I'm just going to draw a rectangle, and I'm just going to click because I prefer to use the dimension tool rather than to type in those boxes, but you can also type in the boxes. This one is going to be, if I zoom in the view cube, you can see Y is up, so this one's going to be Y. Enter. This one, again, to the view cube, X. This is X. And then we're going to grab the rectangle tool. And starting anywhere on the side except for the middle, because if you start in the middle, you see that you get that triangle. And that triangle indicates a midpoint constraint. We don't want that. I want to start about here, and I want to go to about here. And I usually start loose and then get tight with dimensions. It's a lot easier to work that way. And then I'm going to select this little side here, and I'm going to do thickness. And these are going to be our tabs. But for the width of the tab, I want to have exactly one, just like on this one, I want to have just one tab centered on each side. And I want the size of this tab to be 1/3 of the height of that panel. In order to do that, the easiest way is to make a dimension, and instead of typing a number, you can actually click other dimensions and reference them. So I could either click this and say divided by 3, or I could just type Y divided by 3. It's up to you. So now if I change Y and modify parameters, if I change Y, for example, to be 100, you see that also gets smaller. But you see that when I make it smaller, it goes to the wrong place because I made its size parametric, but I didn't make its location parametric. And you can actually see these little blue lines. A blue line in Fusion means something that can be moved. You can see it can be moved up and down. So I'm going to make another dimension using the D tool or sketch dimension, which might live in here depending on the size of your screen. And I'm going to go between the bottom, this, and this. And you can go between the point and the point, or the line and the line, or the line and the point. It doesn't matter so much. And for this, just because I'm lazy, I'm just going to click this one because it's the same size. They're both y divided by 3. So again, this dimension here is y divided by 3. And this one is also y divided by 3, but if you want to be lazy, you can just click an existing dimension. And now we have a choice. We could mirror this using the sketch mirror tools. That's a totally good option, but I don't think it really saves that much time. So I'm just going to draw it again. And then D. And here I can either type thickness or I can just click this dimension. Same thing. And for this, I can either type y divided by 3 or I can just click this one. And then for this, click that one again. We're also going to do the same thing on the top, not on the top, no, on the top and the bottom, because this is the bottom. Sorry, I got confused. We're going to do the same thing on the bottom and the top here, because this is actually the bottom of our piece. It's not the side, so it needs to have tabs on all the sides. So dimension here. Another option, if you don't want to do dimensions, is you could actually select the lines, like these 3 lines, and then click the equal button. And now those are set to be equal. And I can do the same thing for this, and this one, and holding shift to select multiple things, and then I click the equal button. But you have to use a dimension for the, oh, that was wrong. That's not equal. It's not right. So I got to go in and get rid of this one. This is the equal constraint, and you can actually delete constraints if you get in close enough. So you see right there. There you go. I can delete that constraint because that was a mistake. Because this isn't equal to that. It's equal to divided by 3, it's equal to this divided by 3, or x divided by 3. And then this one, now I can do equal, because that was 2y. But for if you need to reference, you can only use the equal thing for things that are like entities on their own. You can't use it for like this distance because there's no line there. You'd have to make a construction line or something, and I don't think that makes that much sense in this context. Great. So now what we have is we have a sketch. Everything is black, and again, when everything is black, it means that everything is constrained and nothing can be moved. And it's fully parametric. So if I go into the parameters, and I make both of these 80. Can't see much, but you see that it all still works out. So I'm going to click OK. I'm going to click Finish Sketch, and then I'm going to use the Extrude tool, which you can launch with the E button, to extrude this out. And usually I like to just grab things and move them around a little bit just to make sure it's doing the thing I like before I type a number, but that's totally optional. And the number in our case is going to be the word thickness. And you can see now we have the bottom. But the sides are separate parts. And if you watch the tutorial in my Fusion YouTube video folder, you'll learn about the difference between parts and components. And essentially, a component is anything that is a separate thing, that moves independently and that exists as a separate part. And it's important to, it's always best to make sure that everything is in, for example, I'm going to call this front/back. If we look inside the bottom component, you can see that it has one body and one sketch. But you can have as many bodies and sketches and other things inside of a component as you want. But there's no reason for this sketch to live outside of this component because it only relates to the bottom. And by working this way, it makes things a lot cleaner and it makes your model a lot more stable. Anyway, so now we're going to work on the front and the back piece. And if you look at the view cube, which I'm going to zoom in on, you can see there's a front, there's a left, and there's a back. There it goes. So this is going to be either the front or the back. And we're going to copy and paste it later because those two parts are actually the same. So I'm going to click New Sketch. And, you know, I could use these planes, but instead I am going to use, it's good practice to remember that you can not only use the 3 planes that come with your model, but you can use any flat surface in your model as a plane. I'm going to use this one. Then I'm going to use the rectangle tool to make a rectangle. And again, I'm just going to make it whatever size, and then I'm going to dimension it with the dimension tool. This is going to be, if you look at the view cube, it's going to be Z. And this one is going to be X. Now you see it's the exact width of the bottom, and I can actually make the bottom invisible if I want, if it's in my way. And I'm not going to, I'm just going to draw the ones on the sides. I'm not going to draw the one on the bottom. Actually, this time I'm going to try using the mirror command just to teach more things. So again, dimension here, thickness, dimension here, Z divided by 3, dimension here, and I'm just going to click this one because I'm lazy, and it makes those two. And now if I go into modify, change parameters, and make the Z 100, everything still works great. Now I'm going to make a line, but instead of a regular line, which looks like this, I'm going to pick the line tool, and I'm going to check the construction box. And what this does is it makes the line a dotted line. And the only difference between a regular line and a dotted line is one, that you can tell that it's construction line has a different style, but also it'll make things easier to select. And I'll show you what I mean in a minute. So I'm going to draw a line between the midpoint of the bottom thing and the midpoint of the top thing. And then I'm going to go to Create and then Mirror. And the objects I want to mirror, I want to mirror this one. Sorry, there's 2 ways of zooming in because I have the, for me, because of the screencasting software. These are the 3 things I want to mirror. And this is the line I want to mirror across. And you can see it just mirrors our geometry. Now I'm going to click Finish Sketch, and I'm going to show you in the Extrude tool. This little rectangle is because this is the thing I clicked originally. It got projected in, so you have to actually click here and here. But you notice that it didn't make 2 regions on the left and right of this dotted line. But if I go back into the sketch, edit sketch, and I make this construction line into a regular line, now it just makes things a little bit more annoying because now I got to click this one, and this one. So the only difference between a construction line and a regular line is a regular line will divide your region and you'll have to select both halves. But just to be thorough, I'm going to change it back into a construction line. Excuse me. And then it's a little bit quicker because I can just click this. I'm going to make the bottom visible so I know which way to extrude. And I'm going to extrude backwards because you see the direction the arrow is pointing. if I drag it behind the plane, you see that the number is negative. So that's a good way to know that I need to actually not do thickness, because that goes the wrong way, but actually do negative thickness. And you might notice that we have a small problem, which is that these two entities are occupying the same space. I'm going to do inspect, color toggling, and you can actually see there's like some fun patterns going on here. Not good. And if I go to inspect interference and select these two things and then do compute, it says, oh no, I found these red boxes are no good. But what's cool is we can actually use those red boxes to our advantage using the modify combine tool. And while it's called combine, it actually does a lot more than that. I can select these two things and want to make sure that this is cut and make sure this is keep tools. And what keep tools means is the second thing I selected, I don't want to delete that just because I'm using it. But if I click OK, now there's no more interference. And if I go into my parameters, make this 12, 10, and make this 160, and this 160, and this 160. Everything's still working. So I'm going to do Control Z just because, I don't know, it looks kind of chunky and too thick for our laser cutter. And now I'm going to make another component. Create new component. Want to make sure that the top level is activated, or else the component will actually live inside of another component. And this one's going to be called right/right left. Because as you can see on the view cube, there we go. As you can see on the view cube, we just did front and back. The bottom we're doing, there is no top, so the other one's going to be called right left. So new sketch, and again I could use this plane because it happens to be right here, but I think it's better practice to click the objects just in case there's something unexpected about your design change. And now I'm going to draw a rectangle from that point anywhere. Sorry, you can double click sides of the view cube if you move your view around and want things to be straight on. And then for the height, just Z. For the width, Y. And actually for this one, that's all we need, because everything else we can do with the combine. So I'm going to click Finish Sketch. I'm going to click Extrude. I'm going to click this one and this one. And again, I got to do negative thickness because positive numbers are this way and negative numbers are this way in this case. Negative thickness, enter. Oh, negative thickness, but no zero. Great, and now I'm going to talk to you about joints. I know I kind of mentioned them a few times in class, but essentially, joints are really important. If I go into, they're really important for mechanical things, such as the utility knife, which we've talked about a few times, where the joint is what allows this to move forward and backward, and really lets you explore your design before you produce it. There's a slider joint here. Similarly, and kind of surprising, there's another joint here. Let's see what joint this is. That's just saying that these two things are connected, that the blade and the blade holder are connected. So joints are just ways of relating two components to one another. You can only use joints between two components. You cannot use joints between bodies or anything else. And right now, none of these things are jointed together. If I grab this orange piece and move it, it just moves away. And again, I can do capture position if I like that movement, or revert to put it back. There are two kinds of joints in Fusion. There are regular joints, which moves components that aren't together, such as the blue handle here, onto the place where it needs to be, using some kind of geometric constraint. But there's also as-built joints, where if the way you built something makes it so they're exactly where it needs to be, you can just say the current relationship between these two things is fine. We're going to use both. So I'm going to use an as-built joint between these two components. And the reason for that is because they're already well related because of the way they were built. And if I just select this component and this component, there's a lot of different types here. In this case, we're using rigid, but if we wanted to, we could also select slider, and then it just needs one more thing, which is like a direction line. And now it's like you can make it wiggle, but you can also give it a rest position. But in this case, we're just going to use rigid, and then OK. And now you see if I try to move this, it moves with the pink one, which isn't exactly what we wanted. And in fact, the pink one is never going to move because it's the bottom. It's like, attached to the ground. So we can right-click the bottom component, and we can actually select ground. And now you see it adds this little thumbtack, this little push pin, onto that one. And now bottom can't move, and anything mated to bottom can't move. Next thing I want to do is I don't want to mess with the green one yet because we haven't yet made it correct, and I'm kind of nervous about making joints between geometry when I'm about to change the geometry. So the first thing I want to do is I want to make a copy of this, and for this one I'm going to use it as an opportunity to just use copy and then paste, and you see it makes another instance right here, the number 1 and the number 2 of the same component. And I could move this, and I could be precise with the movement, and I think I could probably even use parameters for the movement, and maybe it would work, but it's a better practice to actually use regular joints in this case. So this is free to move anywhere. So I'm going to use a joint, not an as-built joint, but a regular joint, because I want the thing to move. And you can select all kinds of points, every corner, every midpoint, every center. All of these things can be selected. The one thing you can't do is your first selection cannot be something that's grounded. And the reason for that is because the first thing you click is the one that moves, and the second thing you click is the one it moves to. You can either just click the thing that you want, but it can be kind of confusing because usually it's like, really ambiguous. Like, do you want that line or do you want this plane? But if you click not on a point, it will then limit your selections to things on that plane, for example. So I'm just going to do this once. So I clicked the plane, X. I clicked the plane first, not on a point, just because I wanted to pick this point here. And I wanted to make sure it didn't get weird. So just click. So that's the point I selected. And similarly, I want to select its friend over here, which isn't this one. It's this one. Oh, so if you click the plane first, then it locks it. There's a lot of different options. There's probably 1,000 different ways to make these two things properly. This is just the one that made sense to me. And now you see these things are locked together. And our type is rigid, but again, you can use all these different types. And now, since these are jointed, if I change the parameters, make this 12, this 140. Everything's all good. And now since this is finally in the right place, I can use the combine tool. Target body is the green one because this is the one I want to change. And tool bodies are the orange one, the other orange one, which for some reason becomes a ghost once you click its friend, but you can still select it even though it's invisible. And then keep tools is really important. And now you can see that our green piece is the way we want it. And instead of doing a joint this time, I'm going to show you a new thing, because there's a lot of ways to do everything in every CAD program, which is, we already talked about the mirror in the sketch tools, but there's also a mirror in the 3D tools, and we're going to use that. The first thing we need to do in order to use the mirror tool, because if we open the mirror tool, you see it asks for an object and a mirror plane. So it's asking us, we need a plane exactly in the middle of this and where it needs to be. And for that, we're going to use the construct menu, which is the menu used to make planes, axes, and points. And we're going to select the mid-plane tool. And I'm going to click this orange face and this orange face. And you see it actually makes a plane, this orange plane here, right in the middle of those two things. Planes kind of show up at a random size because planes go on forever in all directions. They don't really have a size, but if you want to change the way a plane looks, you can grab it and make it bigger. And that makes it easier to select, but it doesn't actually matter. It could be as small as you want and it will still operate the same way. Then we're going to click Create and then Mirror. And the pattern type is important. I want to mirror the component, not the faces or the bodies. Because if I mirror the faces, it could get really messy. It could just make an open box or something weird. If I mirror the bodies, it will put the green thing, two copies of the green thing within the same component. And that's really not what we want. Features won't work at all for this because a feature is not an object, but is instead an operation in the timeline, like an extrude. And that can be useful, but in this case, what we really want is components. And I can either click it here, or I can click it here. And then for the mirror plane, that plane we just built, and you see now we have our box. This plane we're done with now, so I can go into the construction menu and make it invisible. You notice that these two are the same color, and these two are not. And the reason for that is because this one's actually been mirrored, which means that what was the front is now, what was the right side is now the left side. It doesn't matter in this case because it's symmetrical, but it just means that that's one reason why it might be better conceptually to copy and paste. But any change we make to this, for example, will be done to both of them because they're components. So if I fillet this edge, which won't be laser cutterable, so maybe I should have filleted a different edge, but it'll change both of them. And just to show you what I meant about front side, back side, if I fillet this edge, nothing happens on the other one because it's a mirror of the turquoise one. But if I fillet this one, I guess I have to go back in time. If I fillet this edge and then go forward in time with the timeline, you see that it actually mirrors the object. But that fillet is meaningless because we can't laser cut it. I just wanted to show you what I meant by yeah, so that's a way to make a T-light. Going to make these back into reasonable things. 100, 100, 100. And then I'm going to show you how if you can either bring these out and into Illustrator. Oh yeah, the last thing I want to do is do a quick inspect, interference, select everything and do compute. No interference detected. This is good news. Good work, everybody. If you wanted to make this is not necessary because you're welcome to do all the complicated two-dimensional stuff in Illustrator instead of here. But if I wanted to put a toilet or a flower on here, I could insert an SVG onto the face using the, remember our flower, and kind of make it bigger. How big do we want it? Can I do dimensions here? Ah, cool. Nope, yes I can. This won't be parametric because it's a drawing and it's too complicated. I could then go into I could finish the sketch and do an extrude and then do negative thickness. Or if you don't have a parameter, let's say you're doing a different model that doesn't need to be parametric, then instead of doing distance, you could do toObject and just click the backside. And in that case, it's the same as negative thickness. But it's a little bit more general purpose. And you see it did it not only to this one, but to this one because they're components. And I'm going to go into the main thing, and I'm going to take the blue side. See, I'm going to go back in time by dragging back the thing before the mirror. And I'm going to do a new sketch on this one. So, and then I'm going to do insert SVG, find SVG file, toilet, toilet. Oh, there's a problem with this toilet. The problem with the toilet is if I cut it out, there's going to be a floating toilet bowl, which is not how toilets work. So I'm going to make I'm going to add a rectangle here. Going to add a rectangle just like this. I'm going to do finish sketch. I'm going to do extrude. And then if I just click here, it looks like I've done the same thing as 2, but it's actually just measured that. So if I change thickness, it won't work anymore. So it's much better to do negative thickness, or to do, instead of extend toObject and then click. There we go. And now if I go to the main thing, I can drag this forward, and it will mirror the whole toilet. And the reason why, there's a lot of reasons why it's nice to do complicated stuff in Illustrator, like with graphics. One of which is that it's just much easier to handle text and scaling and that kind of thing. Another is that my drawings aren't parametric, and I'm not sure that they can be. So you see, like now the flower is in a weird spot, and if I make this, 50, the toilet's getting cut in half. It's not a good scene. So yeah, I'm gonna save this. When it asks you for a version description, it's just for you. This is just a little message. And where this goes is if you go into your data panel and find out where this got saved. And then click V2, you can see the first time you save it, and then every time you save it, it tells you when it was saved and a picture of it, and also what you typed, if anything. And I typed end of screencast because this is the end of the screencast. So we learned how to mirror components and why it's not usually, it's not as good, just because it means these things aren't linked anymore. If I zoom in, the blue and the turquoise aren't linked, as I showed before. If I fill it this, it doesn't fill it the other one, which is usually not. Usually you want identical things to be linked. yeah, so this is how to make a 5-sided box in Fusion. And again, if I drag this back to just before, so I guess if I want to get rid of the toilets, I can just right-click in the timeline, and actually you can suppress features, and that makes it as if they didn't happen. I'm going to rename this flower, just so you can find it more easily, and I'm going to rename this toilet. Yeah, and again, the parameters work great. I'm going to put the file up as well, but for now I'll just leave it as it is. So thanks for watching the screencast. I hope it was helpful. And email me if you have any questions.